Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I was discussing numerical problems asked in medical and competitive examination. And question I was discussing based on work done in isothermal expansion. Chapter name, all questions are based on chemical thermodynamics, and under that topic was problems based on work done in isothermal expansion. Now I am going to discuss numericals based on work done in adiabatic expansion, and also on relation delta H is equal to delta E plus delta nRT. Delta Ng, small g, means gas, RT. Relation is there. Delta H is equal to delta E plus delta Ng RT. Also you can tell dP and not Qp is equal to Qp. Q means heat, P means pressure. Qp is equal to Qv. Q means heat, V means volume. Means heat at constant pressure is equal to heat at constant volume plus delta Ng RT. Both are same relation in two ways. Okay, delta H is equal to delta E plus delta Ng RT, and in other form you can tell Qp is equal to Qv plus delta Ng RT. Okay, now I am reading the question. 1 mole of an ideal gas is allowed to expand reversibly and adiabatically from a temperature of 27 degrees centigrade. If the work done during the process is 3 kilojoule, the final temperature will be equal to, 4 options are given. Cv value is given. Cv is equal to 20 joule per Kelvin. Cv is equal to 20 joule per Kelvin. Now 4 options are given for answer. First option is 150 Kelvin, second 100 Kelvin, third 26.85 Kelvin, fourth 295 Kelvin. Again I am repeating the question. 1 mole of an ideal gas is allowed to expand reversibly and adiabatically from a temperature of 27 degrees centigrade. If the work done during the process is 3 kilojoule, the final temperature will be equal to, first option 150 K, second 100 K, third 26.85 K, fourth 295 K, means Kelvin. This question was asked in KCET, Karnataka CET, and it will take hardly 15-second time to solve it. Just to think, after that I will tell correct answer and how will you solve that solution I will tell you. Okay, just to think. Its correct answer is 100 K. 100 K Kelvin. How? Now I am telling you, listen carefully. Okay. Now just to read the question, then you will get idea How will you solve? Here, work done during adiabatic expansion, you have to calculate work done during adiabatic expansion. What is its formula? Then its formula is equal to Cv into, in bracket, T2 minus T1, higher temperature minus lower temperature. Then now this adiabatic expansion value is given. Work done during adiabatic expansion. That value, just to see the question, in the question it is given 3 kilojoule. If the work done during the process is 3 kilojoule, it is given, and temperature is given 27 degree, from 27 degree. Okay, temperature is given 27 degree, and during adiabatic expansion, work done value is given 3 kilojoule, and Cv value is also given 20 joule per Kelvin. Now formula I told you, Cv is equal to T2 minus T1, that is equal to work done during adiabatic expansion. Then work done is given 3K, means 3000. Okay, 3K. Then minus 3000, that is equal to Cv. Cv value is given 20, and T2 value you have to calculate, and T1 value is given 27. In Kelvin you convert it. Then 273 plus 27, 300. Then T1 is equal to 300. T2 you have to calculate. Then after solution, T2 value will get, after simplification, minus 300. Minus 300 is equal to 20. 20 is Cv value. T2 minus T1. T2 you have to calculate. T1 value became 273 plus 27, 300. Then T2 value will get 150 K. After simplification, T2 value will get 150 K. First option will be correct, not B. First 150 K. Okay. Then here you have to understand work done during the process. That was given 3K, means 3000 kilojoule was there, then convert in joule, 3000 joule. And work done means energy gotten outside. That is now you can tell minus value is for that purpose. Then correct answer is 150 K. And this question was asked in Karnataka CET. Now next question I am reading. 2 moles of an ideal gas. Next question is 2 moles of an ideal gas at 27 degree temperature is expanded reversibly from 2 liter to 20 liter. Find entropy change. You have to calculate entropy change. R value is given 2 calories per mole Kelvin. Okay, R value is given 2 calories per mole Kelvin. Then 4 options are given: 92.1 second, 0, third 4, and fourth 9.2. Again I am reading the question. 2 moles of an ideal gas at 27 degrees Celsius temperature is expanded reversibly from 2 liter to 20 liter. Find entropy change. You have to calculate entropy change. R is equal to 2 calories per mole Kelvin, it is given. Okay. Now 4 options are there. First option is 92.1, second option is 0, third option is 4, fourth option is 9.2. This question was asked in CBSE PMT and it will take hardly 15-second time to solve it. Just to think, after that I will tell correct answer and how will you solve, I will tell you. Just to think at least. Its correct answer is 9.2. 9.2 is the correct answer. Option D. How? Now I am telling you, listen carefully. Here now you have to calculate delta S. Delta S you have to calculate. Correct? Then delta S means entropy change. Delta S means change in entropy or entropy change you have to calculate. Then now you have to remember the formula. What is the formula? You have to remember. Only then you can solve. Otherwise you will not able to solve. Keep pen and paper with you. Okay. Then at constant temperature, I am telling the relation. At constant temperature, delta S is equal to NR ln V2 upon V1. This is the formula of change in entropy with change in volume. V1 to V2 is there. Then delta S is equal to NR. N small n means number of moles. R is equal to gas constant. Its value is given. N value is small, n value is also given. Number of moles. V1, V2 value is also given. Then what is the problem? Only you put the value, get the result. Delta is equal to n, small n r, ln V2 upon V1. Then now this ln you convert into log. Then you will get 2.303 n r log V2 upon V1. After that n value is 2 moles. N volume is given, n mole, n value is given 2 moles. Then now we will get 2.303 into 2 mole into R value is also given 2 calories is given, R value is also given 2 log V1 upon V2, V1 is given 2, V2 is given 20. Then after simplification you will get 20 upon 2 log, you will get log 10. Log 10 is equal to what? 1. Then just to simplify it, 2.303 into 2 log. 2 log 10 means 2 log 1. Then 2 into 2, 4. 4 into 2.30. Then you will get 9.2 calories per Kelvin per mole. Correct? 2.303 into 2 log 10 upon 2. 20 upon 2. Volume is 20. V2 is 20. V1 is 1. Then log 10. Value you know. You put the value, then you will get the result. Its value will be 9.2 calories per Kelvin per mole. Okay, 2.303 into 4. And 4 into 2, 8 separately coming. Exactly it will come 9.2. Correct? His correct answer is 9.2 calories per Kelvin. Okay. 9.2. You will get the answer. Next question I am telling you. That is based on the relation delta H is equal to delta E plus nRT, means ngRT, G means gas. Now question I am reading. The difference between heats of reaction at constant pressure and constant volume for the reaction 26H5 liquid plus 15O2 gas, oxygen gas, products are given. 12 CO2 gas plus 6 H2O liquid at 25 degrees centigrade in kilojoule. Iitjee. 4 options are given. Minus 7.43, second plus 3.72, third minus 3.72, fourth plus 7.43, plus 7.43. Okay, again I am repeating the question. The difference between heat of reaction at constant pressure and constant volume. Remember, at constant pressure and at constant volume for the reaction is given 266H6 liquid plus 15O2 gas. Products are given 12 CO2 gas plus 6H2O liquid at 25 degrees centigrade in kilojoule. Is first option 7.43, second plus 3.72, third minus 3.72, fourth plus 7.43. It's a correct answer, and how will you solve, I will tell you. And this question was asked in 2 examination, IIT and FMCP, Air Force medical competitive examination. This question was asked, means in IIT also and medical exam also, in both exam, engineering and medical. Just to think how will you solve. After that I will tell correct answer and its solution, how will you solve, I will tell you. Just to think at least. Its correct answer is minus 7.43. Minus 7.43. How then to solve this question? You have to understand first you have to write this thing. Already reaction is given. You have to not write already. Reaction is given. Then you see the reaction carefully. Then easily you can solve. Given reaction is 26H6, means benzene liquid plus 15O2 gas, and 2 products are there, 12 CO2 plus 6 H2O. Then reactant side and product side you see. Then you have to calculate difference between heat of reaction. You have to calculate the difference between heat of reaction at constant pressure and at constant volume for the given reaction, what I told you, at 25 degree in kilojoule. Its value is minus 7.43. How? Now I am telling you. Listen carefully. See here, delta N value first to product minus reactant, number of moles of product minus number of moles of reactant. How many N value will get? How many? Number of moles, then 12 minus 15 means minus 3. Question you see, 12 CO2 plus 6 H2O, that is the product. Then product liquid you have to not consider, only gaseous you have to consider. In gaseous state, then product is 12 CO2, that you have to consider. You have to not consider 6 H2O liquid. In both sides, reaction side also, benzene liquid is there, that you have to not consider. 15 O2, that you have to consider. Then product minus reactant, that is the number of mole. Number of moles, product, number of moles of product minus number of moles of reactant. Then 12 minus 15, that is the minus 3. Minus 3 means now number of moles decreased, means compression took place, compressed. Okay, delta G anyhow calculate, delta N is equal to gaseous state minus 3. Now formula you know. Formula already in the beginning I told you, Qp minus Qv. Qp minus Qv is equal to delta N RT. This is the formula. Or also you can tell Qp is equal to Qv plus delta N RT. Any way you can write. Then Qp minus, because you have to calculate difference at constant pressure and constant volume. That's why you write Qp minus Qv. In question you have to calculate difference between heat of reaction at constant pressure and constant volume. Means Qp minus Qv, that is equal to delta N RT. Delta N is equal to minus 3. R value is, you should know, 8.314. 8.314, that is the R value. You should remember this value. It is important. Sometimes may be given, sometimes may not be given in question. Then 8.314 and divided by 1000. It is in joule. Now you convert it into kilojoule. 8.314 now divided by 1000 to convert in kilo. Then R value you have written, and temperature is 298. 298. Question, in question 25 degrees given. Then 273 plus 25, 298. Correct? Now simplify it. You will get the answer minus 7.43 kilojoule. Okay. Next question I am reading. The difference between delta H and delta E for the combustion of methane at 27 degrees centigrade will be in joule per mole. Okay. First option, 8.314 into 27 into minus 3. First option. Second, 8.314 into 300 into minus 3, in bracket you can write. Third, 8.314 into 300 into minus 2. Fourth, 8.314 into 300 into 1. And fifth option, here 5 options are given. 8.314 into 27 into minus 2. This question was asked in Kerala MEE exam. Again I am repeating the question. Just listen carefully. The difference between delta H and delta E for the combustion of methane at 27 degrees centigrade will be in joule per mole. You have to calculate. First option, 8.314 into 27 into minus 3. Second, 8.314 into 300 into minus 3. Third, 8.314 into 300 into minus 2. Fourth, 8.314 into 300 into 1. Fifth, 8.314 into 27 into minus 2. This question was asked in Kerala MEE. Okay, and it will take hardly 10-second time. Just to think. After that I will tell correct answer and its solution. How will you solve? I will tell you. Just to think. Its correct answer is option C, 8.314 into 300 into minus 2. How? Now I am telling you. Same formula I will use. What I have discussed, same formula. But reaction you have to consider. Again, what I told you, same way. Delta N you should calculate. That is the product minus reactant only for gaseous state, not for the liquid. Then question 2H2O liquid is given, that you have to not consider. For product side 2H2O liquid is there, that you have to not consider. Then product side only one CO2 is there, CO2 1 mole, and product side methane gas is there 1 mole, oxygen is 2 mole, then total 3, then 1 minus 3, that is equal to minus 2. Now same formula you can use what I have discussed. Qp minus Qv is equal to delta Ng RT, then delta N is equal to minus 2, R is equal to 8.314 joule, correct, and temperature is 300, 273 plus given temperature is 27, then it becomes 300, 273 plus 27 in Kelvin, 300. Then you put all three value and simplify it. Minus 2 into 8.314 into 300. You have to not simplify. Directly you have to see the option. Then you will find 8.314 into 300 minus 2. Third option. Now next question I am telling you. The heat of combustion of carbon is minus 94 kilocalorie at 1 atmospheric pressure. The intrinsic energy of CO2 is, first option, plus 94 kilocalorie, second, minus 94 kilocalorie, third, plus 47 kilocalorie, fourth, minus 47 kilocalorie. Again I am repeating the question. This is a good question. The heat of combustion of carbon is minus 94 kilocalorie at 1 atmospheric pressure. The intrinsic energy of CO2 we have to calculate. The intrinsic energy of CO2 is, first option, plus 94 kilocalorie, second, minus 94 kilocalorie, third, plus 47 kilocalorie, fourth, minus 47 kilocalorie. You just to think, it will take hardly 15-second time to solve it. Just you think, at least you think. After that I will tell correct answer and it's how will you solve, I will tell you. Just to think. Now I am telling you its correct answer. Its correct answer is minus 94 kilocalorie. Minus 94 kilocalorie. How? Now I am telling you. Here you read the question. The heat of combustion of carbon is minus 94 kilocalorie at 1 atmospheric pressure. At 1 means normal. Correct? The intrinsic energy you have to calculate. Then here again delta n value first to calculate. And in this case delta E will be equal to delta H. Okay. Then delta n value how will calculate? Then reaction you write C plus O2. C is solid, O2 gas, CO2 is again gas. Then C you have to not consider, carbon solid, you have to not consider, product minus reactant. Then 1 minus 1, that is equal to 0. Delta n value is 0. And here in this case, atmospheric pressure, reaction is going on at atmospheric pressure. Then delta E is equal to delta H in this case. That is equal to minus 94 kilocalorie. How? Now I am telling you. Delta E actually is equal to delta H. Then how delta E will calculate? And delta is equal to delta H. The delta E, how will you calculate? Then delta E, now you have to calculate ECO2. Energy of CO2 minus product energy of carbon and oxygen. Carbon and oxygen, C plus O2, that energy you have to consider. Then here ECO2 minus for both C plus O2 its value is 0, 0. Because both are in elemental state. This is the only important things in this question. C is equal to 0, oxygen is equal to 0. Then delta E is equal to only ECO2. Then ECO2 is equal to delta E, and delta E is equal to minus 94 kilocalorie. It is given in question, minus 94. In question only, the heat of combustion of carbon is minus 94 kilocalorie. And that is the correct answer, because here in this case delta E is equal to delta H. Correct? Hence for this reaction, correct answer for this reaction, this heat of combustion of carbon is minus 94 kilocalorie. Minus 94 kilocalorie. Hence correct option is option B. Option B means 94 kilocalorie. Okay. Now next question I am reading. When the reaction, given the reaction at 1240 Kelvin and 1 atmospheric pressure, reaction is given. Calcium carbonate solid, it is giving calcium oxide solid plus CO2 gas. Delta H value is given, delta H value is given equal to 176 kilojoule per mole. You have to calculate delta E. Delta E. 4 options are given. 160.0 kilojoule, second 165.6 kilojoule, third 186.4 kilojoule, fourth 180.0 kilojoule. Again I am repeating the question. Given the reaction at 1240 Kelvin and 1 atmospheric pressure, reaction given reaction is calcium carbonate solid Products are calcium oxide solid plus CO2 gas, and delta H for this reaction is 176 kilojoule per mole. You have to calculate delta E, and delta E is equal to, four options are given: 160.0 kilojoule, second 160.6 kilojoule, third 186.4 kilojoule, fourth 180.0 kilojoule. This question was asked in BHU, and you can solve it within 15 seconds. Okay, just to think, at least you think. After that I will tell correct answer, and how will you solve I will tell you. Just to think it. Its correct answer is 165.6 kilojoule. Its correct answer is 165.6 kilojoule. How? Now I am telling you. Listen carefully. Keep a pen and paper with you. Here again delta N you have to calculate. Delta N is a formula based. Then delta N for this reaction again, product minus reactant. Only gaseous state you have to consider. Then calcium carbonate is solid, you have to not consider. Calcium oxide, product side also solid, both you have to not consider. Then product minus reactant. Then product side CO2 is there. Product side CO2 is there, it means 1 mole, and reactant side 0. Then 1 minus 0, that is the 1. Delta N is equal to 1. And relation you know, delta E is equal to delta H plus delta NG RT. Delta NG RT. Then delta H value is given 176, and N value is 1. N value is 1. And now this 8, you put the value of R and T. Then R value is 8.314. 8.314, that you divide it is joule, divide by 1000. It will convert kilojoule. And temperature is given 1240. 1240. Okay. And so after solution, after simplifying, you will get 160.6 kilojoule. Correct? Here just you simplify and see what will happen. Delta E is equal to delta H plus Ng RT. That formula you have to use. But here one thing you have to consider delta N value. You have seen product side is 1. Product side is 1. Reactant side is 0. 0. Correct? And delta H value is given. For this reaction, delta value is given 176 kilojoule. 176 kilojoule. Correct? Then here this reaction is taking place at 1240 Kelvin. Correct? 1240 Kelvin. This is the given reaction at, means high temperature. High temperature. Here you have to consider. Then here what you will get, that this value, delta N value is the 1, and rest you will get rest value you will get a relation. You have to calculate. Actually delta formula is given formula is delta H is equal to delta E plus delta NP delta H, but you have to calculate delta E. Hence what will happen? Delta H plus delta H will become minus delta. Correct? Formula if you write for delta E, then delta E will become what? Delta H minus NGRT. There will be change in formula, because you have to calculate delta E. Then delta H is equal to delta E plus NGRT. Then delta E is equal to what? Delta H minus NGRT. And then you put all the values, N value, R value, T value. Then you will get answer plus 176 minus 1 into 8.314 divided by 1000 into 1240. You will get 165.6 kilojoule. Okay. After simplification, you will get this only, because down 1000 is there. You have to multiply by temperature 1240. Then roughly it will go this 176 there, na? It will become exactly after simplification. Some value will deduct 8 more than 8.3. Okay, you will get 165.6 kilojoule. Correct answer will be after simplification 165.6 kilojoule. One more question I want to discuss. Today's last question. The latent heat of evaporation of liquid at 500 Kelvin and 1 atmospheric pressure is 10 kilocalorie per mole. The latent heat of evaporation of liquid at 500 Kelvin and 1 atmospheric pressure is 10 kilocalorie per mole. What will be the change in internal energy of 3 moles of the liquid at the same temperature and pressure? Good question. And 4 options are given. First option is 27.0 kilocalorie, second 13.0 kilocalorie, fourth minus 27.0 kilocalorie, and fourth option minus 13.0 kilocalorie. Correct? Again I am repeating the question. The latent heat of evaporation of a liquid at 500 Kelvin and 1 atmospheric pressure is 10 kilocalorie per mole. It is given. You have to calculate what will be the change in internal energy of 3 moles of the liquid. 3 moles of the liquid at the same temperature and pressure. First option is 27, second option is 13, fourth option is minus 27 kilocalorie, fourth option is minus 13 kilocalorie. All are in kilocalorie. Just to think, this question was asked in CBSE medical examination. It will take hardly 10 second time, not more than that, or 15 second maybe, not more than that. Just to think. After that I will tell correct answer, and how will you solve I will tell you. Just to think. Its correct answer is 27.0 kilocalorie. You have to calculate fast in mind. Okay, it is not difficult. 27.0 kilocalorie. How? Now I am telling you. Listen carefully. Okay. Here just you see the question. You read the question, then it will clear. Latent heat of evaporation That value is given 10 kilocalorie per mole. Temperature is 500 Kelvin and pressure is 1 atmospheric pressure. And you have to calculate internal energy for 3 moles. Then here 3H2 heat of evaporation reaction, you will write 3H2O liquid, it will give 3H2O gas, vapor form. 3H2O liquid will convert to 3H2O vapor, means gas. Then delta N value will be this delta N, number of moles, delta N will be 3 only, because only for gaseous state you have to consider. 3H2O liquid you have to not consider. Then 3H2O gas is there. Then that 3 minus 0, that is the delta N is equal to 3. Actually, this is the important things. Students get confused only there. And now delta N value calculated. Then same formula you have to use. Delta H. Delta H is equal to delta E minus delta Ng RT. That reaction you remember. That is delta H is equal to delta E plus NgRT. But here you have to calculate delta E. Delta E you have to calculate. Hence delta E is equal to delta H minus NgRT. Just you have to transfer this side, left side. Then you will get the value for delta E. Then delta H value is given how much? Delta H value is given this things 500 question 3 moles. Here delta H, delta E is equal to, you will get delta H is equal to 30 minus 3, delta N is equal to 3, correct? And R value and T value you have to put. R value and T value you have to put, correct? Then you will get 27 kilocalorie. Question you have to read carefully. 5, that is latent heat of evaporation of liquid at 500 Kelvin. At 500 Kelvin, correct? And pressure is given 1 atmosphere pressure. That question is given 10 kilocalorie per mole. Per mole. Then for 3 mole how much? 30. This is the important things here. Per mole. Then here 3 moles are there in question. 3 moles are, for 3 moles you have to calculate. Then that value, delta H value is given 10 into 3, that is the 30. 30. Hence delta H value you should write 30, don't write 10. 10 is per mole, but here it is 3 mole. Then 30, correct? 30 minus you have to write delta N value. Then delta N here, I told you that it is the 3. Delta N you have calculated 3 minus 0, that is the 3. Product side 3H2O gas is there. And reactant side liquid is there, 3H2O. Then 3 minus 0, that is the 3. Then N is equal to 3 and R is equal to calories. 2 value you should remember. It is not given in question, but you should remember 2 calories. That calorie convert in kilo. 2 kilocalorie, because the temperature is given in Kelvin, correct? Then 2 divided by 1000 into 500, that is the Kelvin. After that, just to simplify it, simplification is not difficult, and you will get 27. Okay, you have to calculate in mind fast. Simply, if formula you are knowing, delta N you calculated, then quickly in mind you can calculate, because see, 2 into 1000 to 500. 2 will cancel. Then what you will get? 30 minus 7, that is 27. Easily will calculate. 2 upon 1000 into 500. Then 500 into 2, 1000, and 2 will be cancelled. Then what is remaining? Only 30 minus 3, 27. How much time it will take in calculation? Correct? Then its correct answer is 27 kilocalorie. First option. This question was asked in CBSE Medical. Okay, today I am stopping only here. Next class again I will continue. 2-3 days I think it will take time. Then complete full relation, all numericals will be finished, and you will be bold in examination. Okay, thank you.